Hello everyone! How are you? I hope you're fine and able to surpass all the challenges that you have encountered these past days. Today we are going to tackle about hydrocarbons, alkanes, alkenes, and alkynes.
This lesson has come up based from the most essential learning competency. The learners should be able to recognize the general classes and uses of organic compounds. At the end of this video, you will be able to recognize alkanes, alkenes, and alkynes. Name and construct expanded structural formula of hydrocarbons. Find out the importance of knowing the expanded structural formula of hydrocarbons and appreciate the existence of hydrocarbons. Before we go deeper with our topic, let's have a review first of our previous lesson. Refer to the given expanded structural formula. Is this correct? If your answer is no, then you are right. Using our periodic table of elements, we can see that carbon belongs to group 4. Thus, this element has 4 valence electrons. While hydrogen belongs to group 1. Thus, it has 1 valence electron. These two elements share their electrons to become stable. In our previous lesson, we learned that in Lewis electron dot structure, 2 electrons can also be represented with a single bond. Going back to the question, this formula is not correct. It doesn't correctly represent the 4 valence electrons of carbon. As you can see, there are 3 bonds shown. Moreover, this doesn't obey the octet rule, which refers to the tendency of atoms to have 8 electrons in the valence shell, as for the case of carbon. At this point, we are going to write the correct expanded structural formula of this hydrocarbon. Are you done? Let's answer. Obeying the octet rule, carbon will bond to 2 hydrogen atoms. Did you have the same formula of ethane? Well, that's great. Now, let's going to write the Lewis electron dot structure of this hydrocarbon. Let's check. As we have recalled earlier, a single bond is equal to 2 electrons. We will just replace the single bond with 2 dots, which represent the 2 valence electrons. You're doing well! You have learned and understood our previous lesson. And now, I will give you an activity. I will show you the expanded structural formulas of hydrocarbons. Compare the structure and try to recognize if it's alkane, alkene, or alkyne. Yes, you are right. They differ in their bonds. A has double bond, therefore it is an alkene, while B has triple bond in the chain, and so this is an alkyne. C has only single bonds in the chain, thus this is an alkane. Let's try to name these hydrocarbons. A is ethene, B is 1-propyne, C is 2-methylhexane. Now, complete the table shown. You can pause this video and write your answers on your science notebook. Let's now check your answers. There are 3 types of hydrocarbons. The first is given, the alkane. The second type is the alkene, since the type of bond is already given here, which is double bond. And the third type is alkyne. Alkane has single bond, alkene has double bond, and alkyne has triple bond. The given example here under alkyne is butane. Thus,
The example of alkane that has four carbon atoms is the butane, and the alkene with four carbon atom is the butene. The general formula for alkene is CnH2n plus 2. The general formula of alkene is CnH2n, and the general formula of alkyne is CnH2n minus 2. Did you get all the correct answers? Let's deepen your understanding about hydrocarbons. Hydrocarbon is a class of organic chemical compounds composed only of the elements carbon and hydrogen. The carbon atoms join together to form the framework of the compound, and the hydrogen atoms attach to them in many different configurations. Depending on the properties, hydrocarbons are divided into two groups: aliphatic hydrocarbon, the open chain compounds, and cyclic hydrocarbon, the closed chain compounds. Hydrocarbons are the principal constituents of petroleum and natural gas. They serve as fuels and lubricants as well as raw materials of the production of plastics, fibers, rubbers, solvents, explosives, and industrial chemicals. Now, let's focus on the aliphatic hydrocarbons. Aliphatic hydrocarbons are divided into three main groups according to the types of bonds they contain: the alkanes, alkenes, and alkynes. Alkanes are hydrocarbon compounds that only have single bonds in the compounds. Alkanes are also known as saturated hydrocarbons because additional hydrogen atoms can no longer bond in the compound. All alkanes have molecular formulas that satisfy the general expression CnH2n plus 2, where n is the number of carbon atoms. The IUPAC, International Union of Pure and Applied Chemistry system, is used for the naming of organic compounds. We will follow the step-by-step procedure to come up with the name. Let us have this example structure. The first step is to locate the parent chain or the longest continuous chain of carbon. So this is the parent chain of this structure. The second one is to name the carbon atoms of the parent chain starting from whichever end of the chain gives the location of the first branch. So since our first branch is located on the left side, so we will start our counting on the left side. 1, 2, 3, 4, 5, 6. There are 6 carbons in our parent chain. The third step is to name the parent chain. So since there are 6 carbons present in our structure, this parent chain, we will name it as hexane. The fourth step, name the alkyl group attached to the branch. Alkyl group is basically an alkane minus one of its hydrogen atoms. For example, we have the methane. Following the step here, we are going to remove one hydrogen atom, thus it will now form into methyl. So in our structure here, the alkyl group attached to the branch is the methyl group. Fifth, assemble the name, listing groups in alphabetical order. In our given structure, there is only one alkyl group, the methyl, so we don't need to arrange them alphabetically. Sixth, attach the name of the alkyl group as a prefix of the parent chain. So the alkyl group here is methyl. So we are going to attach the methyl in our parent chain, the hexane. Seventh, Place the location of the alkyl group in front of the resulting name. Take note that a hyphen is used to separate the number from the word. So in our example, the alkyl group, the methyl group, is attached in the second carbon. So we are going to name this as 2-methylhexane. And 8, in cases where there are two identical alkyl groups which are attached to a carbon atom, the prefix di is used. The prefixes di, tri, tetra, etc., used to designate several groups of the same kind, are not considered when alphabetizing. So, in this example, there are two same alkyl group, the methyl groups, attached in our second carbon. So we are going to name this as 2-dimethylhexane. The general formula of alkanes is CnH2n plus 2, where N is the number of carbon atom. In our given structure, there are 8 carbons, so N is equal to 8. Substituting N with our value 8, we come up with C8H2, 8 plus 2. Therefore, our molecular formula is C8H18. Let's try to check if there are really 18 hydrogen in our structure. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So, this is correct. And now, let's go to alkenes. Alkenes are hydrocarbons that have one or more carbon-carbon double bonds in their structures. The name of alkene compounds ends in "-ine". Alkenes belong to the class of unsaturated aliphatic hydrocarbons. The general formula of alkenes is CnH2n, where N is the number of carbons in the structure. To name alkenes, the rules used in naming alkanes will be applied. However, the parent carbon chain must include the double bond even if it takes it shorter than the others. Again, numbering of the parent carbon chain starts from whichever end gives a double bonded carbon. The location number should be given as to where the double bond is. Let's take this as an example. In our example, the double bond is found at the right side. Therefore, we are going to start our counting at the right side. Let's start to count. 1, 2, 3, 4, 5, 6, 7, and 8. There are 8 carbons in our structure. So we are going to name the parent chain or the longest continuous chain of carbon. And since there are 8 carbons and the double bond is found at the second carbon, it is 2-octene. We're going to name the alkyl group attached to the branch now. So as you can see, there are 2 alkyl groups. The first one is ethyl and the second one is methyl. At this point, we are going to assemble the name listing groups in alphabetical order. Since ethyl starts with letter E while methyl starts with letter M, we're going to write ethyl first and methyl will come after. Let's now locate where the ethyl is being attached. So ethyl is attached at the 5th carbon, so this is 5-ethyl, while methyl is attached at the 2nd carbon, so this is 2-methyl. So our alkene here is 5-ethyl, 2-methyl, 2-octene. Did you understand? Very good. Now let's proceed. Let's have the general formula of alkenes, which is CnH2n, where N refers to the number of carbons in our structure. So the given carbon here is 11. Thus, substituting the general formula CnH2n,
we come up with C11H2 times 11. So this is C11H22. Let's check if there is really 22 hydrogens in our structure. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So our structure is correct. Let's now proceed to the third hydrocarbon, the alkynes. So alkynes contain at least one carbon-carbon triple bond. Take note, triple bond. Also, it is unsaturated hydrocarbon just like alkene due to the presence of at least one triple bond between carbon atoms. The general formula of our alkynes is CnH2n minus 2. And of course, it ends with -ine. In naming of alkynes, the rule is the same as those in alkanes and alkenes, but should end with the suffix -ine. Let's have this example structure. So, what do you think is the name of this alkyne? Yes, you are exactly correct. It is 2,4-nonadiene. So, let's now proceed to our application. Let's name the following hydrocarbons. Number 1. You are correct. It is 2-ethyl butane. Number 2. You are correct. It is 2,4-diheptene. The third one. You are correct. It is 2-hexene. Now, let's try to draw the expanded structural formula of the following hydrocarbons. Number 1 is 2,3,4,5,6,7 hexamethyloctane. Are you done? Let's see if you are correct. So this is the expanded structural formula of 2,3,4,5,6,7 hexamethyloctane. As you can see, our alkyl group is found at the second, third, fourth, fifth, sixth, seventh carbons in our structure. Thus, there are 6 methyl or alkyl groups attached in our parent chain. That's why it is 2,3,4,5,6,7 hexamethyloctane. Let's have number 2. 5-methyl-3-octene. Are you done? Let's check. So this is the expanded structural formula of 5-methyl-3-octene. As you can see, the alkyl group attached here is methyl. And methyl is found at the 5th carbon in our parent chain starting from the left side. Number 3. 3-methyl-octa-1,4-diene. Are you done? Let's check. So this is the expanded structural formula of 3-methyl-octa-1,4-diene. So as you can see, there are 2 triple bonds attached. So this is an alkyne. Number 4, 4-pentyne. Are you ready to make your expanded structural formula of 4-pentyne? Okay, done? Let's check. So this is the expanded structural formula of 4-pentyne. I guess you're ready for our assessment. You can take a screenshot so that you have a guide. Number 1. Recognize the following hydrocarbons: alkane, alkene, or alkyne. Letter A, 2,6,7 hexamethylheptane. B, 3-methyl-4-hexene. C, 4-methyl-2-hexyne. Number 2. Choose one hydrocarbon from the given and using the materials available, Construct its expanded structural formula. Again, A is 2,6,7-hexamethylheptane, B is 3-methyl-4-hexene, and C, 4-methyl-2-hexine. For number 3, you answer this in a paragraph form. What is the importance of knowing the expanded structural formula of hydrocarbons? In giving grades of your output, these rubrics will be followed. There are 3 criteria: accuracy of content, labels, and creativity. For accuracy of content, 10 points if it is less than 10% of the lesson is shown in the diagram, 20 points if less than 50% of the lesson is shown in the diagram, and 30 points if at least 90% of the lesson is shown in the diagram. For labels, 10 points if it is important items in the diagram are not labeled, 20 points if many important items in the diagram are clearly labeled, 30 points if all important items in the diagram are clearly labeled. And for creativity, 10 points if the materials of the diagram are not coordinated, the diagram is done poorly, the output is constructed for the sake of compliance. 20 points if the materials of the diagram are not so well coordinated. The diagram is presented nicely, the output is just okay. And 30 points if the materials of the diagram are well coordinated. The diagram is neat and well presented. The output is virtually appealing. So the highest score for this output is 100%. If you have questions, you can message me directly in my FB Messenger or email me in my depth email address. Okay? For your assignment, answer this question. What is the difference between hydroxyl group and carbonyl group?
Did you learn something from our lesson today? I hope so. So to send your output, you can send it in my messenger or send it in my email address, or you can upload it in the shared Google Drive, or you can visit me here in the school. So see you. So that's all for today and have a nice day. Bye.